So when you strip the impact of seasonality out of actual data, you're going to work back to a number that's close to the trend. But sometimes it's not going to be exactly the same. And that's what we're going to pick up in this activity. In this activity, we've got some actual numbers, 4700, and we're told the trend is 4400. But the difference between these two numbers may not be fully accounted for by seasonal factors. There might be some other factors going on here. Is that all seasonal? Well, we can work out by deseasonalizing that actual number. So if we're told that the seasonal factor is 0.85, it means that unemployment is normally low in that quarter. So if we want to work out the seasonally adjusted figure, giving an indication of what the trend is, that's going to be 4700 divided by 0.85, and that gives 5529. So the answer is A, 5529, and that's showing you the actual adjusted for seasonality, and it should give you something close to the trend. Where it doesn't, which is the case here because the question said the trend was 4400, it must be because there's some other factor, some residual one-off factor coming into play. So in this context, we're talking about unemployment, or perhaps a major employer has suddenly closed down out of the blue. Nothing to do with the trend, nothing to do with seasonality, it's just happened. Well, that would explain why the actual adjusted for seasonality is different from the trend. So that's the idea of deseasonalizing. You deseasonalize the actual data. So we've been trying to identify seasonal variation so that we can do some forecasting. We're now going to bring together the calculations of trend and seasonal variation and show how we can do a forecast. And this is going to involve, first of all, calculating the average trend growth. Secondly, using that trend figure to forecast, to extrapolate, to look ahead. And that will allow me to predict what the trend's going to be doing in the future. And then finally, I'm going to adjust the trend either by adding seasonal variation or multiplying by seasonal variation. Now, an exam question, a multiple choice question, is not going to be asking you to do all of those things, but could easily ask you to do any one of them. So we're going to work through these three steps using some sales data for swimwear. And again, we've got 3 years and we've got 4 quarters. So the actual information is given. To work out the trend, we'd have to do a centered moving average. That's been done for you. Then to work out seasonal variation, we would compare the actual data to the trend data and work out the average variation in each quarter. This has been done for you. Here we're using the additive model. So remember, that means that the time series equals trend plus seasonal variation. So quite a lot has been set up here. The requirement is to calculate sales for the last quarter of 20x7 and the first quarter of 20x8. So looking back to the information, we've got actual data up to the third quarter of 20x7 and we're now forecasting 2 quarters ahead. So that's the requirement. The first step is to understand exactly what's happening to trend. Now we've got the trend figures here. The trend figures have risen to 57,000 from 40,000. And that's happened across 1, 2, 3, 4 quarters. So on average, we could say that the change in the trend is 17,000 over 4 quarters, which is an average of 4,250, 4.25 thousand per quarter. So that is the average trend growth, and that's step 1. And now that we've got the average trend growth, we can extrapolate, forecast the trend, and then step 3, we can put in the seasonal variation, which we're going to add in because the additive model is being used here. So to calculate my forecast for Q4 20x7, I need 2 things. First of all, the trend for Q4, and then the seasonality for Q4. So just looking back for a minute, the information for trend that we were given actually relates to the first quarter of Q4. So when I take that 57, I have to recognise that it's for the first quarter, and if I'm trying to forecast the trend for the fourth quarter, then I've got to put in quarter 2, quarter 3, quarter 4, 3 quarters of growth at the trend growth of 4.25 per quarter. So 3 times 4.25 is 12.75, and 12.75 on top of the trend gives 69.75. And while I'm at it, I'll do the next quarter as well, because I'm being asked to forecast that. So that's going to be another 4.25 higher, and that takes me to a trend of 74. Once I've got my trend figures, the rest is very straightforward because I'm given the seasonal variation. For quarter 4, it's minus 14.25, and for quarter 1, it's minus 18.25. And these numbers appear here. And all I'm going to do, using the additive model, is bring the trend numbers down by the seasonal variation, and I've got my forecast. So now we've got an activity, which is exam standard, asking you to forecast sales in the first quarter of year 4. So you're going to have to go through the same steps that we've just illustrated. This is important and it's exam standard. So can you pause the presentation and have a go at the activity? So first of all, we need to identify the average trend. In this question, the trend values are given in brackets. So the first trend value I've got is 18.75, and the final one is 22.75. So I can see that the trend has grown by 4 over 1, 2, 3, 4, 5, 6, 7 quarters. So that's about 0.57 per quarter. Now I've got the average trend, I can forecast, and I can forecast what the trend is going to be in the first quarter of year 4. And to get to the first quarter of year 4, I've got to take the existing trend figure and take it ahead 1, 2, and then a further 3 quarters. So starting from the latest trend figure of 22.75, I've got to add on 3 lots of 0.57, and that means that the trend estimate will be 24.46 for the first quarter of year 4. And now that I've got the forecast trend, I can apply the seasonality. Looking at the average seasonal variations, they're not grouped slightly above or below 1, so it's clear that we're using the additive model here. And therefore, once I've got the trend figure, I add or subtract, and here it's subtract, the seasonal variation. So 24.46 less 0.1 becomes 24.36. And that's the forecast.